Newton's method problems are best done with a chart. If I were to ask you to find the zeros of x squared minus 2, well, of course you could do that. You could just say, okay, well, x is plus or minus the square root of 2. But what if you can't? And I ask you to use Newton's method to approximate a zero, and I tell you to start at x1 equals 1 as your initial guess. So you're going to come down here, you're going to make x1 equals 1 as your approximate, it's your first guess. You're going to find the slope of the tangent of that line. There is x2, and you repeat the process. So make a chart. This is your x value. This is your f at x. Now, I want you to go and write the function in the chart. This will help you. F prime, taking the derivative of this, is 2x. Now, I want to point out these other two. These are just to help you. This next column is Fn divided by f prime. So I'm going to put a little block above it. All right, so the next column is the ratio of these two. The last column is this column, xn minus your ratio. So by setting this up very neatly, you're going to be able to do the iterations in a very straightforward manner. Now let's start putting data in. Let me go to red. This is my initial guess is x equal 1. So I'm going to put x equal 1. And I, in general, want to include a bunch of zeros because these are going to be very, you're going to need them. Now, the next top thing I want to do is find f of 1. So this is 1 squared minus 2, or negative 1. The next thing I want to do is find f prime of 1. So this is 2 times 1, or 2. Don't let the numbers fool you. It's going to get messy quick. The next thing I want to do is find f of 1 divided by f prime of 1. And this is negative 1 divided by 2. So this is 0.5. Now, the last thing I want to do is find x minus f of 1 divided by f prime of 1. And so this is 1 minus, you know what, I left off my negative sign there. Don't do that. Minus 1/2, or 1.5. So this is my approximate point. This becomes x2. So 1.5 goes down here. Now I'm just going to change colors. Those are the same numbers. You don't have to do this. Now let me find f of 1.5, and that's 1.5 squared minus 2, or 0.25. I'm going to do a couple things to save some space. F prime of 1.5 is 2 times 1.5, or 3. And then the ratio of these, now do you see this? Do you see I can just sort of, I've lined them up, and now you can see I have my ratio here. So I have these in my calculator, so I'm just going to go on and put in, this is 0.0833333, etc. I'm going to put it down here just to help you while you're trying to figure these out. All right. All right, there's my decimal. And then my last term is 1.5 minus 0. Left off my 0 there, 0.0833. And this number is 1.41667. 1.41667. So this number right here goes up here. Now I'm just going to change the color of it. This is, you do not have to do this. I'm just showing you because I'm doing each one in a different color. Let me come on down here. I'm going to need to extend my page a bit. The next term I need is f at 1.41667. And so this is 1.41667 squared minus 2. So this becomes 0.006945. 0.0069. Oh, can't read that, can I? 0.006945. Now, what is f prime of 1.41667? Well, this is f prime is 2 times 1.41667, and this gives me 2.83334. All right, so f divided by f prime, that's all I'm doing right here, is 0.006945 divided by 2.83334, and I get 0.002451. All right, 0.002451, and my term, my x of 3, is x, or my x of 4 is x of 3, so it's 1.41667 minus 0.002451, and so I get a final iteration of 1.414216. So this is my answer. All right, so this would be the number that goes right here. This is using 3 iterations, Newton's method, to approximate a 0. And this is actually pretty close.